Welcome to Food Technology 1, FOT 150S. My name is Vusim Shaisa, and today we're going to be talking about sorting and grading of foods. Perhaps the question is, what is sorting and what is grading of food products? Well, I hope we are going to learn more about what do these two terms means during the presentation. Before I begin, please like, subscribe, share, or comment on these videos. It takes some effort to create these videos. Let us know how we are doing. So, let's go back to the content. Have you ever went to a retail outlet to buy, for example, a certain fruit? Let's take peas for an example. When you got there, you found that they were not in the same shape or size that you expected. Well, that might be disappointing at times, but these things happen when we do not sort or grade foods before they reach the consumer. The shape of food is important in determining its suitability for processing and the retail value, right? So most of the raw materials are priced based on their shape. For example, irregular shaped potatoes will sell at a lesser price than compared to regular shaped potatoes. For economical peeling, potatoes should have a uniform oval or round shape without protuberances. So this is very important in the food industry. Let's take cucumbers for example. Cucumbers and gherkins are more easily packed if they are straight, right? So that makes the process go a little bit faster and easier to manage. So shape sorting is accomplished either manually or automatically in the food industry. Therefore, these two are very important. So if you look at grading, so if you go and buy eggs, you normally hear they say these are small eggs, these are medium eggs, these are large eggs, these are extra large eggs. And you also sometimes find it with fruits and vegetables, where if you go to the Belleville market, you'd see that they say it's an A grade, it's an AA grade, it's an A plus grade. So those are materials that have been graded. So in this course, we're going to find out what are the characteristics that are being used to grade foods, and more importantly, what type of equipment can we use to grade food in the food industry. So how is the presentation going to go? We are going to look at sorting and grading as two distinct unit operations. Remember, previously we spoke of cleaning as a unit operation. And this unit operation, we said, it's a unit operation in which there is a separation of components, right? So we're going to show how this also goes. So here, these are also separation techniques. So we're going to look at the general considerations, the type of equipment that is used, and we're also going to look at grading. So what is the aim? The aim is that you as the student should be able at the end of this presentation or video to define and identify the differences between sorting and grading. Furthermore, you should be able to explain the importance of sorting and grading operations in relation to common foods and processes. So here we're looking at the particular food products. How do you grade potatoes? How do you grade carrots? How do you grade onions? Processes, what type of equipment should be used, right? And what is the mechanism behind? So you should also be able to describe the various methods used in the industry to sort and grade foods, and further relate these methods to specific processing applications. Very important. Always stress application. So when we assess you, we also want to see whether you can be able to apply the knowledge that you have gained, right? So let's look at the introduction. So sorting and grading are terms which are frequently used interchangeably in the food industry, right? But strictly speaking, these are two distinct operations. So what do we mean by sorting? Sorting is a separation based on a single measurable property of raw material, right? So here you sort the materials based on a single measurable property or an attribute. While on the other hand, if we're talking about grading, so here where grading is the assessment of the overall quality, underlying overall quality of food using a number of attributes, right? So perhaps Slindo Kuhle, we are asking, how does this play, say, in real life? I've made an example in the beginning with eggs. Eggs are graded into a grade small, medium, large, extra large. You also find what they also call jumbo. So once you see this distinction, it takes an overall assessment of the egg yolk, the color of the egg yolk, the shape of the egg yolk, right? The weight of the egg yolk. In some cases, perhaps you might have seen when you do eggs for breakfast, you open an egg and then boom, there's 2 egg yolks. Wow, that's a gain, that's a win. Perhaps that is an extra large egg that you have, right? So these are graded in food processing. But also we look at quality parameters. Are there any blood spots in the egg that you have? Right? So what is the level of blood spots? Is it too much, or is it too less, or is it negligible? So those are factors that can be used in order to grade, to give the eggs a grade. We also have the same thing when it comes to fruits and vegetables such as apples. Apples can also be given a grade where you've got an A+ grade, you've got an AA grade. This is also mostly important. We also have meat that is also graded or classified, right? It can be lean meat, right? It can be a C grade, it can be an A grade, it can be a AAA grade. So these are definitions that we need to understand, that sorting one particular attribute, separating the components, the raw materials based on a single attribute, but when we are grading, we're looking at the overall attributes. So let me refresh your memory a little bit. So when we spoke about cleaning, we said cleaning is a unit operation in which we want to remove or separate the contaminants from the raw materials, because these contaminants may cause people to get sick, or they may also cause ill health, right? And we said we also want to clean raw materials because we want to control the microbial loads to reach a level that is acceptable for further processing. And then we said cleaning as a unit operation in the food industry is essential for the protection of the process equipment, but also as well as the final consumer, because we don't want the consumers then to get sick. So now when we look at sorting is a unit operation that is very important for controlling the effectiveness of the process, right? So raw materials that are graded, so they are better suited for mechanical operations. So if raw materials are sorted, they are better suited for mechanical separations such as peeling, blanching, pitting, and coring. Sorted raw materials, they're further important for processes which require heat transfer, for example, such as retorting. Why is this important? Because now when you have raw materials which have not yet been sorted, right, it can result in, for example, if you've got a variation, let's say you've got a variation in terms of the pieces of a meat that you're going to can. So the smaller pieces, they are going to be cooked faster compared to the bigger pieces because of the heat transfer is not the same in these two materials. So size there plays a role. So we need to sort the raw materials before they are processed. Sorting also ensures that there is better control over the weights which is filled into standard containers. So for example, if you're going to have canned peaches, right, so when these are filled, you need to make sure that the size is the same or the shape is uniform so that you can be able to fill your products correctly there. Also, consumers prefer materials or raw materials that are uniform in size when they buy products. This is important, especially in the case of peas, right? So you want to have peas that have uniform size. So now, if we look at grading, so grading is a separation into different categories of quality. And so quality is different. Remember, we spoke about quality the other day and said quality is what determines consumer acceptance, right? So for example, if I pass there at the robot and then there's this guy who's selling avocados and they are nice green and they appear really nice, so I would judge the quality as acceptable, right? So if you are a farmer or you are a processor who receives avocados, you would want to grade your avocados based on the acceptability, based on color, based on firmness, something like that, right? So you can say these one, they are much softer, so we're gonna give them a grade, so they will go first, and then the harder ones, they stay below, right? They stay back. So you can also have materials which is ready for the food processor. So acceptable quality is normally regarded as good quality for final product, right? Because remember, when we spoke about the raw material in the process, we said the nature of the raw material will determine the final product quality. If you've got poor raw material coming in, I really doubt that your final product is going to be of a high quality, right? So the good raw material, the good final product. So what are the considerations that needs to be taken during sorting and drying? So we know that most fruits and vegetables are sorted and graded for marketing and have a role in protecting and hence enhancing product quality. So these two unit operations play a very important role. So they help in reducing cross-contamination of healthy stock destined for storage, transport, distribution, marketing, and processing. So the other day I went to Food Lovers Market, then I bought some oranges. So the oranges, you can really see they were not really sorted very well, because when I got home and I opened the sack, there was an orange inside with green spots, which is mold, right? So here now, if I did not open these oranges, they were going to stay longer, and then this orange was going to start contaminating the others, resulting in a shorter shelf life for my oranges. So good thing that I opened the oranges when I got home. So it's very important that raw materials are then sorted before processing. And also product damage and during handling. So you need to be able to sort these raw materials to prevent this problem. So what are the sorting machines and what are the principles that you find in the food industry? So the principles, so materials can either be sorted based on the weight, the size, the shape, the photometric characteristics. This will include things like the color of these materials, and here is the name again, aero and hydrodynamic characteristics. So basically water and air dynamic characteristics of these materials, and we can also look at the surface nature of the raw material. For the purposes of this presentation, we're not going to look at all of them, but we'll do some considerations for this. So let us start with weight sorting. So in the food industry, weight is considered as a reliable method for sorting foods, since it is not dependent on the geometry of the products. Therefore, it is used for more valuable foods. For example, weight sorters are replacing mostly the size and dimensional sorters in the food industry. So if you have meat or any piece, the weight of foods can be computer weight and priced per weight. So this is good, because what now manufacturers are doing is to price the goods of the raw material, the goods or the raw materials based on the weight, right? So and then there are various reasons for that. It may be that the soluble solids content is higher. If it's higher, maybe there's more proteins or there's more nutrients, right? So if we've got eggs, fruits or vegetables, they can also be separated into weight categories using spring-loaded strain gauges or electronic weighing devices incorporated into the weighing system. And so the question is, how is this achieved? So this is what we're going to try to find out. So if you look at the weight sorting mechanism, the first thing that we note is that fruits can be carried in tarred canvas pockets that are connected to pivoted beams, which are fitted with a counterbalance weight. So as these fruits, as you can see here at the bottom of the picture, these pivoted beams contains a counterbalance which weighs them. And then as the beams they pass the sorter, the beam fulcrum is moved towards the counterbalance weight until the fruit causes the beam to tip. So therefore the fruit is then discharged into pedal chutes in weight categories depending on the weight that the fruit has. The second mechanism that we can also see is what they call the catapult system. So whereby the fruits are fed into adjustable spring-loaded catapult arms that held in the fruits into 12 paddled collection chutes. So for example, here the principle is that so this height trajectory uses a height trajectory, and as the collection chute is released to the fruit weight. So the lighter, as you can see, the green ball there would then go further. So the lighter the raw material, the further it travels, and then it's collected on the different beams. So this is basically what are the mechanisms that can be used for weight sorting. So what about size sorting? Size sorting is less precise than weight sorting. As I've mentioned previously, that weight sorting is a very precise. However, size is less precise, but it's considerably cheaper, right? So here we find two types of sorting mechanisms. We find what we call using fixed aperture screens and variable aperture screens. So under fixed aperture screens, you've got flatbed screens, you've got drum screens, which can be series or in parallel, and then under variable apertures, you've got continuously variable apertures or stepwise variable apertures. So how does these things work, right? So if we want to sort raw materials, so the sorting process into size categories requires some sort of a screen that you should then use. In the case of flatbed and rotary screens, these are the main geometries of fixed screen beds that are used, and they have a number of screens which may be used in series, or they can also be used in parallel to sort the units into several categories simultaneously. So the sorting mechanism happens simultaneously. However, the problem with these fixed screens is usually contacting the feed material with the screen, which may become blocked or sometimes also overloaded. So this is the problem here. So In most cases, fixed screens are used with smaller particulate foods, such as if you want to have nuts, and if you also want to have pears, right? The first screen that we find is what we call a series type consecutive drum screen. So as you can see here, the feed comes in at one end, and then the smallest particles, so you've got so this will be a variable screen, because you've got screens apertures that are variable. So you've got a smaller size in the beginning, and then the middle, and then the bigger size. So as the drum rotates, right, the smaller materials, they come out and then they are collected at the bottom. Then the middle materials, they come out in the middle and they are collected in the bottom. And then you've got the larger pieces, and the largest materials then would be come out at the end. So this is basically how these consecutive drum screens functions. We can also have a roller sorter type of a screen, which basically looks at the size. So at the top you've got a fixed aperture, and then at the bottom these driven rollers, then they enlarge. So as the material comes in, so these balls, they are rotating, so the smaller size will then go out, and then the bigger size will go out towards the end. So larger units, they move downhill where the gap is larger and fall here. So let us look at an example of an orange sorting principle. So here we've got oranges of various sizes, and then they go into these machines, and then these machines have got screens, and then they start to be collected. So if you look at this section, this side, so these are these drums now rotating at various speeds. So at this moment the speed is very low, and then it will go on the other side. So as the material goes through, where it can go inside, if it's smaller, then it gets collected on the first rail, right? So this is just not really the industrial process, but it's what farmers are using. And I like to show these small scale kind of unit operations, so that you as a student can also be inspired to start your own business, to start your own operation. I think this is not really very expensive. We need more entrepreneurs who will be food scientists. So here you'd see that the smaller oranges or narches, they come out first, and then at the end you've got the larger narches that are coming out there. So that, now we've looked at weight sorting, and then we also looked at size sorting. Now we're going to look at shape sorting. So what is shape sorting? So after size sorting, some of the raw materials could still be contaminated with undesirable constituents that are of the same or similar size with the raw material. And this is very important, especially in the case of wheat, right? So where you find that the shape of the contaminant and the raw material is could be different, and this is used on the basis of sorting. The size is the same, but the shape can be different. So let's look at how these function. So here we have what we call disc sorters, right? So these disc sorters, they function by collecting the material of the desired shape in the indentations. See where the material is hiding there, so that we call that an indentation, right, on both sides of the rotating vertical disc. So the disc rotates vertically. So the banks of disc are mounted on a rotating shaft with the lower ends of the disc passing through and unsorted raw materials. So the materials, you may find that the contaminants will not be able to fit into these discs, right? So with each rotation, the desired raw materials are collected in the indentations and are deposited into what we call collecting troughs, right? So these collecting troughs collect these desired raw materials, and then these discs are also designed for specific seeds which are available. So for example, if you've got sesame seeds, if you've got sunflower seeds, if you've got, for example, rape seeds, so those are the disc separators that can be used today. So we also have what we call the belt and roller sorter. So the belt and roller sorter, what it does, it's part of what we call a variable aperture screen, right? So remember that variable aperture screens may either be continuously variable screens, or they can have what we call the stepwise increase in aperture screens. So the stepwise increase in aperture screens are produced by adjusting the gap between the driven rollers and an inclined conveyor belt. So here you've got a conveyor belt coming in, transporting the materials, and there you also have rollers. So at the first part, you've got a very small gap between the roller and the conveyor belt. Therefore, the materials that are huge will not pass out there. Then the second time, then you have the medium and then the larger part. So then you also have a collection tray which collects these raw materials. So what basically happens is that the food rotates, and the same dimension is therefore used as a basis for sorting. So this basically is some kind of a diameter sorting that is used here. So these are belt roller sorters. They sort based on the size of the raw materials. So the other thing that we know is that the raw material color can also be different, right? So how do we then sort raw materials based on the color? So we use what we call photometric sorting. Photometric sorting, for example, this is a larger or amplified picture, which you've got a vibrating chute where the hopper, where the raw materials come in, and then they travel through a conveyor belt. So this conveyor belt, you've got colored backgrounds which are basically computerized, right? So they look at there are different pictures that have been taken, which forms part of the library. So if there's any foreign color that is not known, then it triggers a detection system using compressed air. So Atsenkos, now you are asking, but say, I still don't understand. Can you please repeat? So what I'm saying here is that color sorting is based on characteristic reflectance and transmittance of light property of the material. Because of color, go back to your physics notes. So color we have reflectance and transmittance, right? So reflectance is when the light is shown into the material, then it reflects back a signal, or it can either transmit, right? So light can pass then through the material. So the reflectance indicates certain things. In this case, the reflectance indicates the level of maturity of the raw materials in terms of color. It can also indicate the presence of surface defects. If there's any defects that are present in the materials, for example, it can be a bruised fruit. It can also indicate the extent of processing, and this is very much used in baked biscuits. On the other hand, if you've got transmittance will then look at the internal properties, which are, for example, the ripeness of the fruit. Are there any core defects inside, maybe inside the grapes, or if you've got the case of eggs, are there any blood spots that are present in the eggs, or any extraneous matter inclusion, so if there's any unrequired material. So both of these, they use what we call gamma rays, X-rays, UV light or visible IR, microwaves, and radio frequency waves. So let me show you an example. So this now is an enlarged picture. So you'd have your material coming in here. You'd have your material coming in here, so which this is unsorted material, and then you've got photocells over here. So this is the compressed air, which is a rejection system. So this is configured such that the good quality material will be the clear material, so this will be let to pass through. But if this photocell detects the black material, it's going to be on the rejected part. So this is how it works. Let us look at an example in the form of a video here. Right. So this is the processing of grapes in the reception area. So grapes have got different types of contaminants that are present there. Some of them, they are not on the right shape, or some of them, they are not on the right size. So this machine takes that to the destemmer. So the destemmer is where the stems, they are removed. So now this is a very gentle separation processes of berries from the stems, or also grapes. In this case, then if you look at them, then the grapes that are heavy, then they go through the conveyor belt going up, and then here I've got a vibrating screen to remove maybe any other foreign matter that may be present, insects, pits, and then now you've got a very high speed conveyor belt, which then takes in these grapes. Some of the materials will then fall down because they do not get into the conveyor belt, and those materials, they are collected. So this is what they use for controlling the feed. Also operates as a sorter. So here you also have what they call the camera. So you remember the photometric cell that I've shown you, so which takes the pictures of these materials as they pass. So these are cameras with color and infrared detection. So as the material passes, compressed air removes those materials that are not desirable. It shoots them at a very high speed. So this is a process that takes very happens very quickly at a very high speed, right? But this is very fast. So any material that is not required, it's thrown out of the process. And then these materials that are not required, they are collected as waste. So you can see here, these are rejected particles of the grapes. And then on the other side, you would have the material that is still acceptable for further processing. And mostly it's perfect result, or a perfect scenario. So these processes of sorting raw materials, separating them, can also be mechanized, right? So in other example, I'll show you a non-mechanized process. So we have what we call reflectance sorting. This is what I've already now explained. And also in the transmittance, for example, in the use of eggs, which is a process called the candling of eggs. So let us look at the candling of eggs.
It rotates the eggs so that they're all in the same position throughout processing, and it washes them. They use a specialized solution of water and soap to clean and sanitize the eggs. The water temperature is about 106 degrees Fahrenheit.
This is a dirt detection system. It used to be someone's job to look at all these eggs going past and pick out the ones that had spots of dirt on them. Now the eggs cruise right past an array of 16 different cameras. The eggs are rotating as they pass through, so the cameras can see all of the eggs. The shots from the cameras are analyzed by this computer. If it sees a spot, that egg is automatically routed off to the side and back in the washer.
Josh, music? We both need a good grade on this.
Oh, fine.
Speaking of sound, I thought this was interesting. It's a crack detector, and it checks the eggs sonically. Tiny probes tap each egg and listen for the sound it makes. If the sound has a high pitch and sustained ring, the egg is fully intact. If it's more of a thud, there's a crack somewhere, and that egg will be routed to a different line. The cool thing is how fast all this happens. The eggs don't even slow down, because the machine taps and listens to each egg 16 times in a matter of seconds.
Some places still candle the eggs, but this is how they do it now. Much faster and more efficient than the old way. And this is the modern version of the one egg at a time scale. The eggs pass over sensors built into the line, all controlled by a computer. Each egg is weighed over 60 times in under a second. There's only a 3-ounce difference in weight per dozen between different sizes of eggs, like medium, large, and extra large.
The eggs then go through this grading machine. These machines are huge and can handle millions of eggs a day. Once the eggs have gone through all of the inspections and grading, they're sorted to separate lines for packaging. The eggs are sorted by grade and size. This is a line for grade A, large eggs. There are other lines for grades AA and B, medium and large sizes too.
Big farms like this one fill orders for several different grocery outlets, so they'll run different cartons depending on their orders. Some stores specify fiber cartons, while others might use foam.
Advanced technology is used in the packing. The date information is burned into the cartons with a laser.
So basically that shows the process of how eggs can be treated. So the other mechanism that we can use here is what we call buoyancy or density sorting. So we know that density can be a marker for suitability for certain processes, right? So the density of peas correlates well with the tenderness and sweetness. So while the solids content of the potatoes, which determines suitability for the manufacture of crisps and dried products, relates to density. So sorting raw materials on the basis of density can also be achieved using flotation in a brine at different concentrations. So as explained in aspiration cleaning, we can also use pneumatic classification, hydrodynamic sorting, water sorting the raw materials using in water, as explained in froth flotation of cleaning of apples. So the combination of aerodynamic and shape sorting, so for example where the material is fed on the upper end of an inclined chamber and the chamber is porous and creates an air slide effect in the separating materials in terms of the shape. So I want to pause here now and so that you can then reflect on these techniques that we have learned. So this basically covers the sorting operations, how these raw materials are sorted. So we can sort the raw materials based on the weight, based on the size, based on the shape, based on the color properties, whether we are looking transmittance, whether we're looking reflectance, or we can also use buoyancy. And then you need to know the equipment that you're going to apply for each material. For